In this video, I'll be talking about electric field due to a point charge. So let us consider we have a charge here. The charge is Q, and we are interested in finding out the electric field at point B at this point, which is at a distance r. Okay, so we assume we have test positive charge. This is a unit test positive charge. So we keep a unit test positive charge at point Q naught, where we are interested in finding out the electric field. Now from the Coulomb's force, we know that there will be a force between these two charges. So let's find out what is the force. So the force between these two charges is given by this formula here, this formula, where K is a constant, Q is the magnitude of this charge, Q naught is the magnitude of this charge, and R is the distance between the two charges. So this is the force acting between the two charges. Now if you want to find out the electric field at this point B, then what we have to do, that divide this force by this charge here. So the electric field at that point is defined as the force at this point divided by this charge. That gives the electric field. Now if we divide the force by the charge, then you see from this equation, if I divide force by this charge Q naught, then the electric field, this will be the electric field, KQ over R squared. So the electric field at any point is defined as KQ over R squared. This gives you the formula, the equation for calculating the electric field at any point. Remember, K is a constant. What's the value of K? 9 times 10 to the 9 Newton meter square per Coulomb square is the unit of K. The unit of electric field, as you know from this equation, it is the force divided by the charge. So what is the unit of the force? The unit of force is Newton. And what is the unit of charge? It's Coulomb. So what is the unit of electric field? It's Newton per Coulomb. That's the unit. That's the unit of the electric field. So now let me talk about the direction. The electric field is a vector quantity. It does have a direction. If you have a positive charge, an isolated positive charge, then the direction of the electric field is always outward. It is always outward. And if you have a negative charge, an isolated negative charge, then the electric field is always radially inward. What does this mean? That means if I bring out a unit positive test charge, if I bring a positive charge here, the force will be along this direction. If I bring a positive test charge here, the force will be along this direction. The same thing here, as this is a positive charge. If I bring any positive charge, the force will be along this direction. If I bring it here, the force will be along this direction. That gives you the direction of the electric field. Let me show you a simulation here. So in this simulation, I will talk about the electric field. So this is a positive charge, and the arrow, so all the arrow that you see here, that tells you the direction of the electric field. So now if I bring out the sensor, so you see at this point the electric field is, the red arrow gives you the direction of the electric field, which is radially outward. If I bring the sensor at other point, that gives me the direction of the electric field at that point. And since this charge, the main charge is a positive charge, this charge, the electric field is always radially outward. If I bring the sensor here, that gives me the electric field at that point. Okay, so what is the electric field? The electric field, in a simpler way, can be thought of as a region around a charge where if we bring any other charge, that charge feels a force acting onto it. Okay, the stronger this charge is, the greater will be the electric field. If we move further from this charge, just like here, then the value of the electric field starts decreasing. If we bring it closer and closer, then this value keeps increasing, and if we move further, then this value starts decreasing. Okay, so the electric field depends upon the magnitude of the charge and the distance. If we move further away, the value starts decreasing. If we come closer and closer, the value starts increasing. All right, so that's it for the electric field. In the next video, I will talk about the